In this problem, we need to show that the left-hand side of the equation is equal to the right-hand side of the equation. Since we're starting with something a little more complicated on the left, I'm going to bring that down and work from left to right rather than right to left. All right, so I have sine x minus cosine x plus 1 all over sine x plus cosine x minus 1. And I'll copy that over to the right-hand side here, and we can work off of that. Okay, so what I'm going to do is I'm going to turn this 3-term expression into a 2-term expression by putting parentheses around sine x minus cosine x in the numerator, and I'll do the same thing in the denominator by putting my parentheses around sine x plus cosine x. And then I'll put brackets, because what I'm going to do here, the whole purpose in making this into a 2-term expression, is that I'm going to now multiply by the conjugate of either the numerator or the denominator. And generally speaking, they both work. In this case, I'm going to go with the conjugate of the denominator simply because in the expression I'm looking to form, the denominator is a little bit simpler. So I'm going to multiply both the numerator and denominator by sine x plus cosine x plus 1, because that's the conjugate of the denominator. I just changed the minus into a plus here. And then I'll put the same thing in the denominator. Okay. Just get rid of that. There we go. Okay. So now, in the next step, I'm going to multiply this out. So I've got sine x minus cosine x in parentheses I'm trying to write small to squeeze this all in. It gets quite long at one point. And that's going to be multiplied by sine x plus cosine x. So that's my first in terms of FOIL. Then I have the outer, which is sine x minus cosine x times a positive 1. So that's just sine x minus cosine x. And then I have 1 times sine x plus cosine x. That'll just be sine x plus cosine x. And then I multiply the last together, and they're both 1s. So I go plus 1. Now this is all over. In the denominator, I'm going to do the same thing. So I have sine x plus cosine x times another sine x plus cosine x. So I'll just make that sine x plus cosine x quantity squared. And as I said before, I'm going to use the difference of two squares here. So the inner and the outer cancel. That was the whole reason for changing the sign from minus to plus when we multiplied. So now I have just a minus 1 on the end there. Next, I'll simplify, combine like terms, multiply out, do that good stuff. Just make sure that you're not doing too many steps in one just because it's fairly simple algebra. So now I have sine x minus cosine x times sine x plus cosine x. So again, I can use the difference of two squares formula. And this will give me sine squared x minus cosine squared x. And then I have a plus sine x and another plus sine x. So that gives me plus 2 sine x. and then we have minus cosine x and a plus cosine x, and those two terms cancel out, and then there's a plus 1. Okay, so that's looking a lot nicer. Now in the denominator, I'm going to use the perfect square trinomial formula on sine x plus cosine x quantity squared. And this gives me sine squared x plus 2 sine x times cosine x plus cosine squared x, and then the minus 1 is on the end. Okay. Oh, don't need an equals right there, do we? Okay, so now on my next line, I'm a bit stumped when it comes to the numerator. So this is where I'm going to show you what do you do when you get stumped with one part or with your whole expression and you can't see how to move forward to the other side of the equation. But in the denominator, I do have some things that I can do. So I'm going to work with the denominator, simplify that a little bit more, and hopefully that'll give me a hint as to what to do next. Now what I did was I just changed the order of the terms. So I took the plus 2 sine x cosine x, put that at the end, and now I have sine squared x plus cosine squared x minus 1 plus 2 sine x cosine x. So in the next line, I'm going to have to go to a separate page here. Okay, so now I'm ready to start up again here. I've moved over to a separate page. You're going to start seeing that more often where it takes more than one page to do a problem. Okay, so I have sine squared x minus cosine squared x plus 2 sine x plus 1 in the numerator. Not really sure where to go with that. But I can, in the denominator, make the sine squared x plus cosine squared x minus 1 plus 2 sine x cosine x. I can work with that a bit. So what I'll do is simply, I copied down the previous expression, and now the sine squared x plus cosine squared x, I'm going to turn into a 1. So I have 1 minus 1 plus 2 sine x cosine x in the denominator. And now I can cancel the 1's. 1 minus 1 is 0. So I just have 2 sine x cosine x left in the denominator. Now this is the point where I got stuck and thought, well, what is it that I can do? How can I use the identities that I'm allowed to use in order to manipulate this into what we're looking for on the right-hand side of the equation? And when I really get stuck on this kind of thing, what I'll do is I can't just start working on the right-hand side and get to this middle. But I kind of can do that as long as I do it off to the side, nobody knows about it, and then we just keep writing our steps. So if I work from the right to the middle, then I'll just reverse those steps and continue on till I get to the right-hand side of the equation. So I'm going to go off to a separate page, and I'm going to look at this, compare it to what we have in the right-hand side of our original equation, and see what to do next. Okay, so now what I know is if I should be able to get to the right-hand side, these two expressions must be equal to each other. And notice that the denominator, we've gotten awfully close to what it is that we want. So what I'll do is work from the right-hand side in reverse and see what I can do from there. So I'm going to stop this video here, and then I'll pick up in the next part. Okay, so now I have this equation, and I'm trying to work from the right-hand side to get to this middle part from the previous problem. So let's see what I'm doing here. Okay, so I know that I want my denominator to turn out to be 2 sine x cosine x, working from the right to get over to the left-hand side here. So what I'll do is I'm going to take sine x plus 1 over cosine x and multiply both the numerator and the denominator by 2 sine x. And then what do we get? All right, well, I'll distribute the 2 sine x in the numerator, and I've got 2 sine squared x plus 2 sine x. So now my question is, well, how do I get what I have to look more like what's on the left-hand side now? Oh, I forgot to bring down my 2 sine x cosine x. There we go. Okay. Well, I have a sine squared x on the left-hand side, and I have 2 sine squared x on the right-hand side. So what I'm going to do is I'm going to make this into a sine squared x plus another sine squared x plus 2 sine x. And that's all over 2 sine x cosine x. Now, what have we got so far? I've got my denominator to be what I want it to be. And I have a sine squared x term here and a sine squared x term here. And I have a 2 sine x term here and a 2 sine x term here. I should say plus 2 sine x in both of those cases. So now, what's left over? I have a minus cosine squared x plus 1, and I have a sine squared x. So I know that I need to use my Pythagorean identity in order to bridge the gap between these two expressions. So how can I rewrite sine squared x to make it into 1 minus cosine squared x? Now, if you were to manipulate the Pythagorean identity, then you could do that directly, but we're going to say, no, you can't change the identities. We're going to use them just as they are. So what I'll do here is I'm going to take that middle sine squared x, and I'm going to add a cosine squared x to it. Now let's see how that's going to be in any way helpful. So I've got sine squared x, and that is just going to stay as it is, plus another sine squared x. And that one is going to be changing. And now I'm going to add cosine squared x because I know I want to work with the Pythagorean identity, and this is going to become 1. But if I add cosine squared x, I have to subtract cosine squared x also. And that way I'm not changing what I had originally, as long as I also bring down the 2 sine x. And then this is all over 2 sine x cosine x. All right. So now what I have is sine squared x, and sine squared x plus cosine squared x is 1. So I have a plus 1 minus cosine squared x and plus 2 sine x. And this is over 2 sine x cosine x. So now, other than the order of the terms, I've got what is on the left-hand side here. So this is how I'm going to manipulate. So from the left-hand side, what I'm going to do is come down to here and say, let's see, so I've got sine squared x plus 1 minus cosine squared x plus 2 sine x, and then I can work my way from there. So the idea here is that this plus 1 in the next step is going to become a sine squared x plus cosine squared x, and that's what I was looking for. What is the key here? So it doesn't necessarily need to look identical to what I have here and then work my way back up to the top there, but in essentials, that's what I'm going to do. So I'm going to take that plus 1, turn it into sine squared plus cosine squared, and then see what that does for my problem. So coming back over to here, now I'm ready to continue. Okay, so I'm going to bring down what I have, And the only thing I'm going to change is that plus 1. I'm going to turn into sine squared plus cosine squared. Okay, so, oops, put in my sine squared x plus cosine squared x. And there we go. So now I can combine my like terms. I've got sine squared x plus another sine squared x, and that gives me 2 sine squared x. And the cosine squared x, positive and negative, cancel each other out. So those are gone, and I have a plus 2 sine x. And this is all over 2 times sine x times cosine x. So now I can factor a 2 sine x out of the numerator, and that leaves me with sine x plus 1. You can see where this is all coming together now. And 2 sine x cosine x in the denominator. The 2 sine x's cancel, and I have what was my goal, which is the right-hand side, sine x plus 1 all over cosine x. And that's the end of my problem.